So we left off with the stratum lucidum. We're in the epidermis of the skin. The stratum lucidum is found only in the palms of our hands and the soles of our feet. Let's see if I can brighten this up a little bit. And it has keratinocytes. It has that translucent layer. And then our last layer is stratum corneum. It's the outermost or uppermost layer of epidermis. It has up to 30 layers of dead keratinized cells, and they are flaking off of that outermost layer. So this is again providing protection, resistance to abrasion or penetration, and even evaporation. So this talks a little bit about keratinocytes. I'm not sure that we need to talk about their life history, but they are starting by stem cells in the stratum basal, and then they are moving up through the stratum spinosum, and this is when mitosis is occurring, and eventually they're pushing up as newer cells are being divided in that basal or spinosum layer. Once the epidermal cells are 2 or 3 cell layers away from that dermis or the stratum basal, that's when the mitosis is over, and they're just going to continue to be pushed up by new cells below them. So about 30 to 40 days it takes for a keratinocyte to make its way to the surface and eventually flake off. Talks about cells are growing flatter as they move upward, which we already mentioned in the previous video. But then in the granulosum, 3 kind of developmental mile markers happen. The nucleus and the other organelles degenerate, and that is the death of the cell. The granules are releasing a protein, and then the vesicles release a lipid mixture that helps to waterproof the cell. So we talked about that water barrier as being one of the functions of the integumentary system, but that specifically happens between the granulosum and the spinosum. So this is just showing you those darker flattened cells right at the layer in between granulosum and spinosum is where that specific waterproof barrier is happening. This helps to retain water in the body, preventing dehydration. The cells above that barrier are quickly dying because the barrier cuts them off from nutrients. So they are not getting any nutrients, and then eventually they are exfoliated or falling off. So deep to the dermis, below the dermis, is a connective tissue layer. So the epidermis was epithelial tissue, but the dermis is connective tissue. Again, we have a range of thickness, 0.2 millimeters in our eyelids, all the way up to 4 millimeters in our palms and soles. We know from connective tissue that we're going to see a matrix, then with some cells inside, and that's exactly what happens. We see some collagen and elastic fibers, reticular fibers, but then there are cells within there as well, fibroblasts. This layer is well supplied with blood vessels, sweat glands, oil glands, and nerve endings. When we look at the dermis, we'll see hair follicles and potentially nail roots if we're looking at fingers and toes. They are embedded in the dermis. We'll also see some smooth muscle with those hair follicles. Pulls to those smooth muscles contract so that the hair stands up. It contracts in response to a stimulus such as cold or fear, and that's what makes goosebumps. Up at the top of that dermal layer, we'll see what's called the dermal papilla, and it's finger-like extensions. It kind of looks to me like the stratum basal, where it looks kind of up and down, kind of like a wave. But that's the boundary of the dermis and the epidermis. So within the dermis, we have 2 layers, the papillary layer, and then below that is the reticular layer. So the papillary layer has a zone of areolar tissue, and that allows for the leukocytes to get there and other defense cells to move in if the epidermis becomes broken. This area has lots of small blood vessels. And below that is the reticular layer. This is made of the dense irregular connective tissue. This talks about the collagen fibers can be torn when we have stretching of the skin, and that's what produces stretch marks. Okay, so there's up close picture of the dermis. Again, that kind of wavy look is the boundary between the epidermis and the dermis. Okay, below the dermis is the layer called the hypodermis. It's called the hypodermis, or it could be called subcutaneous layer. Either one will work. It's made of more areolar tissue and also adipose tissue. I can always tell the hypodermis because of all that adipose that you see. They look like little bubbles. It helps pad the body and helps connect the skin to the underlying tissues. When we inject drugs, we inject them here into that kind of fat layer.